In our everyday world, rules feel solid. A wall stops you. A locked door blocks you. A mountain stands in your way. But in the quantum world, the rules soften. Boundaries blur. And sometimes the impossible becomes normal. This is the story of quantum tunneling, a phenomenon so strange that it feels like a glitch in reality. A place where particles slip through barriers they should never cross. A place where probability becomes motion. A place where the universe quietly says, the rules are different here. To understand tunneling, we must understand the terrain. At the smallest scales, particles are not tiny balls. They are waves of possibility. They spread. They overlap. They exist in many potential states at once. An electron does not sit in one exact spot. It occupies a region. It vibrates with probability. This wave-like nature is not a metaphor. It is the foundation of quantum mechanics. Every particle has a wave function. It describes where the particle might be found. Tall wave, high probability. Small wave, low probability. Zero wave, impossible. This wave is the electron's identity, its presence, its footprint on reality. And this wave is the key to tunneling. Imagine an electron moving through space. Ahead of it stands a barrier, a region of energy higher than the electron has. Classically, the story ends here. The electron hits the wall. It bounces back. It cannot cross. But the electron's wave function does not stop. It leaks into the barrier. It fades, but it does not vanish. And if the barrier is thin enough, if the wave can stretch through to the far side, something remarkable happens. The electron appears beyond the barrier, not by climbing over it, not by breaking it, but by tunneling through it. A particle that should be trapped escapes. A rule that should be absolute bends. This is quantum tunneling. Tunneling feels supernatural, but it is not magic. It is mathematics. Inside the barrier, the wave function decays. It shrinks quickly, but it never reaches zero. And because it never reaches zero, there's always a chance, even a tiny one, that the particle will be found on the other side. Quantum mechanics does not ask, can the electron cross? It asks, what is the probability that it will? The universe becomes a casino. Particles become gamblers. And tunneling is the rare moment when the improbable becomes real. The rules are not broken. The rules are simply deeper than we imagined. Quantum tunneling is not a small detail. It is not a scientific curiosity. It is one of the foundations of existence. Without tunneling, the sun would not shine. Inside the sun, hydrogen nuclei repel each other. The repulsion is enormous. Classically, they should never fuse. The barrier is too high. But quantum tunneling allows them to slip through the barrier. Fusion happens. Light is created. The sun glows. Every sunrise is a quantum event. Every photon that reaches your skin is a reminder that tunneling keeps the universe alive. Let's return to the electron. In a metal, electrons move freely. In an insulator, they are trapped. The barrier is too high. But even insulators leak. Electrons tunnel through thin layers. This is how flash memory works. It stores information by controlling tunneling currents. In scanning tunneling microscopes, electrons tunnel between a sharp tip and a surface. By measuring the tunneling current, we map atoms one by one. Tunneling is not rare. It is everywhere. It is the quiet engine behind modern electronics. To feel tunneling, imagine the electron's wave function as a soft, glowing fog. As it approaches a barrier, the fog presses against it. Some of the fog seeps inside. Most of it fades. But a faint whisper reaches the far side. If that whisper is strong enough, the electron can appear there. The electron does not travel through the barrier. It does not carve a tunnel. It does not squeeze through a crack. Instead, the universe chooses a location that matches the wave function. The electron is not a traveler. It is a possibility that becomes real. Quantum mechanics forces us to rethink motion. In the classical world, motion is continuous. A car drives from point A to point B. A ball rolls across the floor. But in the quantum world, a particle can be at A and then at B, without ever being in between. This is not teleportation. It is the collapse of a probability wave. The particle does not cross the barrier. It simply appears where the mathematics allows it to appear. Reality becomes probability. Probability becomes reality. Quantum tunneling is not just a cosmic trick. It is a tool we use. Tunnel diodes. They switch extremely fast by using tunneling. Flash memory. Electrons tunnel into and out of floating gates to store bits. Scanning tunneling microscopes. They measure tunneling currents to see individual atoms. Quantum computers. Tunneling influences qubit behavior, especially in superconducting circuits. Fusion reactors. Even artificial fusion relies on tunneling. Tunneling is not a glitch. It is a resource. One of the deepest mysteries of tunneling is time. How long does a particle spend inside the barrier? Does it move faster than light? Does it move at all? Experiments suggest that tunneling may be almost instantaneous, or so fast that classical intuition fails. Some interpretations say the particle never truly enters the barrier. Others say the wave function interacts with the barrier in a way that defies classical motion. The truth is still unknown. Tunneling is not just a phenomenon, it is a question mark carved into physics. Quantum tunneling is not only about electrons, it is about us. It shows that the universe is not rigid, not deterministic, not limited to simple rules. It shows that the impossible can happen, that barriers can be crossed, that probability can become reality. In a way, tunneling is a metaphor for human creativity, for breakthroughs, for moments when we push through obstacles that should have stopped us. The quantum world is not separate from us. It is the foundation of everything we are. Quantum tunneling is one of the most beautiful ideas in physics, a reminder that the universe is stranger and softer than we imagine. Electrons do not break the rules. They reveal deeper rules. Rules written in waves, rules written in probabilities, rules written in possibilities. Reality is not a prison of certainty. It is a playground of potential. This is quantum tunneling, a doorway through the impossible, a whisper from a quantum world, a reminder that even the smallest particles can do extraordinary things. Thanks for watching, and I'll see you in the next chapter of this digital adventure.